In Greek mythology, they thought the moon was a goddess named Selene. She traveled across the night sky along the same path as her brother Helios. Well, I'm pretty sure the Greeks were wrong and that the moon's not a goddess. But where did it come from? Well, about 4.6 billion years ago, when our solar system began to form, there was all sorts of debris around the ball of gas that would become our sun. We call this debris the solar nebula. In it, there were all sorts of different kinds of rocks of different sizes, and they were made of different materials. Closer to the sun, where it was warmer, these rocks were made of materials with high melting points, like iron. Further out, where it was colder, they were made of materials with low melting points, like ice and gases. Well, you can imagine that if one of these rocks was slightly bigger than the rocks around it, it was more massive and would have more gravity. Imagine this as a snowball rolling downhill. As this slightly bigger rock went around the sun in its orbit, it would gather other rocks to it, and it would grow. Now, we call what this rock was growing into a protoplanet. So as it goes around the sun, it gets bigger and bigger. Well, one of these protoplanets formed between the Earth and Mars. But there's really not enough room there for another planet. So one day, this protoplanet, which we named Theia, for the mother of Selene, that moon goddess, ran into our Earth. Bam! And it crashed. Out of the debris, there were some rocks that were slightly bigger than the others. They came together, and they formed our moon. So that's how the moon formed. But what would Earth be like if we didn't have it? Well, in our solar system, our moon is unique. It's very big compared to our Earth. OK, my Play-Doh's not to size. But it's very big. It's about a quarter of the diameter of the Earth, and it's about 1% of its mass, which is huge whenever we're talking about moons. Well, this massive moon that we have tugs on the Earth by gravity. This is what gives us our tides, high tides and low tides. Additionally, this big tug on the Earth helps to stabilize the Earth's tilt, its axis tilt. So our tilt can go anywhere between 0 degrees and 90 degrees. But it likes to stay around 23.5 degrees. Our moon helps keep it there. It's the tilt of our axis that gives us our seasons. So you can imagine that if our tilt was going all over the place all the time, our climate would be very erratic. This could have prevented life from evolving on Earth. So without our giantly massive moon that Theia gave us, we might not even be here today.
Is that on? Can you hear me? Great. Very nice presentation. You have great energy, nice bringing us in right away and grabbing us. And I thought the subject matter was really interesting. The use of props is always great, as we've talked about. If you're going to use them, slow down a little bit. Show us them a bit more. You were sort of all over the place with them. Right, so make sure that we're seeing them and they're out in front. Now, the interesting thing about the hair thing, and I know we're not supposed to talk about physical, how everyone is, but since you brought it into your presentation, the only thing I would say is be careful, because when you came up on stage, it was sort of really sticking out.
Yeah, it splintered back
Yeah,
then.
no. And I once worked with the guy who's head of sports from Fox, and he had this great observation, and he said, you can have the greatest commentator in the world, but if his tie is crooked, all people are going to see is his tie is crooked. They're not going to hear what he's saying. So for a while, all I kept looking at was the stick sticking out. So, and it's great that you used it as a prop, but just be careful it doesn't become a distraction, So, but really nice.
Thank you.
Love the use of the props, and I like how you kept sort of pulling stuff out of your pockets like a magician, and they would change. And to have that visual of, the relative sizes, I thought was great. Your enthusiasm clearly came through, and subject matter was fascinating. So good job.
Thank you.
Ditto. And nicely constructed narrative, and you have a very engaging manner and a nice pace to your speech. Thanks.
Ditto all of that. I love the way you sort of naturally, the props kind of appeared out of your pockets or out of your hair. In fact, I was waiting for you to take the scarf and start using that somehow. But no, it was really well done. And the only comment I have is that the ending seemed pretty abrupt, and I kind of went, what? Oh, she's done. And the rest of it was sort of so flawless in the way you shaped it that I'm not sure, even just sort of pausing a little bit before you make your dramatic final statement that without the moon we wouldn't be here. Something about the pacing at the end you just need to round out a little bit. But other than that, I thought it was wonderful.
Thank you. So as Dr. Wojtek reminded us, astrobiology is the search for life in the universe. Well, as an astrobiologist, we often struggle with the fact that we only have one example of life here on Earth. Well, let me take you on a journey to an alien world. This world's not like Earth, with our 80% nitrogen and 20% oxygen atmosphere. It has no oxygen whatsoever. And it's constantly being bombarded by meteorites. You may think, why are we going here? This sounds like an awful place to go. Well, life is on this planet. And not only is it on this planet, but it emerged, it evolved on this planet. We didn't get to this planet in a spaceship. We got there in a time machine. This is Earth, 4 billion years ago. About 4 billion years ago, whenever our Earth was beginning to form, there was all sorts of debris in our solar system, and it was smashing into the Earth with all sorts of meteorites. But these meteorites were a good thing. They brought all sorts of gases that added to the volcano gases in our early Earth, but they didn't add any oxygen. They added gross things to our atmosphere, like methane and sulfur and carbon dioxide. About 3.8 billion years ago, life evolved on this planet. It wasn't plants or ferns or the mold from your bathtub. It was microbial, single cells, like germs. And we don't even know if they look like the microbes from today. These microbes would have used that sulfur and carbon dioxide from the atmosphere to grow, like you and I use sugar and oxygen to grow. You might think, well, there were all those meteorites, right? They were bombarding the planet, so they would have just killed them, right? Well, no. Those meteorites brought wonderful compounds, organic compounds, like sugars and the building blocks of DNA. Those microbes use those. Additionally, those meteorites created hydrothermal vent systems, like Yellowstone National Park. Well, if you've ever been to Yellowstone, you know the microbes are there, they're thriving. So these microbes eventually evolved photosynthesis. You think, great, now we have oxygen. Now we can really get things going. Well, this oxygen was devastating to these microbes. They had never lived in an environment that had oxygen, so it was a catastrophe. It was toxic to them, similar to sulfide and arsenic is to us. Well, that oxygen helped make it so that multicellular life, like you and me, could evolve. Hop back in our time machine, come back to present-day Earth. As an astrobiologist, I can take comfort in the fact that I have two examples of a habitable planet. Today and early Earth. Thank you.
Stay there.
Oh,
yeah, you're
okay.
right. Now there is going to be some questions. Oh, sorry, by the judges. Thank you.
So, Becky, thank you. That was a really enthusiastic and passionate and interesting presentation. I have one question for you. You stated near the beginning that life didn't come to this planet from somewhere else, but formed here. Could you say very briefly why you believe that's true?
Well, so I guess I would say that we don't really have the answer to that, about whether or not life emerged on Earth or if it came from somewhere else. Right now, to our best knowledge, we don't know of life on any other planets. So our best guess is that it evolved here. The environments that we know of that would have been taking place on early Earth, the bombardment of meteorites, bringing those organic compounds that I talked about, makes it seem like it might have been a good environment for life to emerge from. But like I said, we don't have any concrete evidence that that's exactly what happened.
Can I ask a quick question? If you could tell me in 50 words or less, how did you choose to study a subject like astrobiology?
Well, to be honest, I wasn't sure what sort of science I wanted to study. I always knew I was interested in science in general. I was always like, you know, the kid that went to recycle and save the environment. But I did an internship actually with NASA in high school. And as luck would have it, Mars was really close that summer. So I ended up spending a lot of time researching Mars. And I came across the science of astrobiology, and I thought, wow, this is really cool stuff. I could make a living, or at least get to do that for the rest of my life. I'd be pretty happy. So I stuck with it.
Thank you so much. Great job.
Thank you.
I think that was 53 words. I'm sorry. No, I think it was a great enthusiasm, and I think one of the things you did really well here was you took the audience on a journey. You brought them back in time. So I guess the question I have for you is, if you indeed had that time machine as an astrobiologist, what's the one thing you would have liked to have seen?
Well, do I have to go back in time, or can I go forward in time?
I'll leave it up to you.
Well, personally, as an astrobiologist, I'd love to go forward in time to see whenever we first make our discovery of life on another planet. I'm sure that that's something that will happen, and I'd love to see what it looks like and what our society looks like whenever that happens.
Great, thank you.
One more.
I have a question. Is it on? You have a number of young people in this audience, and I want you to tell them why they should be interested in astrobiology and consider it as a topic of study when they get to be in college or high school.
Absolutely. Like I said, astrobiology is the search for life elsewhere in the universe, but it's also a study of the evolution of life in the universe, and we are part of that life. So in my mind, the future of the human race and of life here on Earth really depends on astrobiology and us moving, you know, similar to the quotes we heard at the beginning of this lecture on moving out and colonizing other worlds. So without the field of astrobiology, none of that's really possible. So whenever we're looking at our long-term future as young people, astrobiology is really at the forefront. Very good. Thank you.
Thank you very much, Becky.